Alright, now it's time for us to practice calculating speeds and feeds. And the instructions say, why is it necessary to know the correct cutting speed and feed rate? The reasons are varied. If a higher than unnecessary speed is used, it can cause a tool to wear, to break, or to chatter. They can all be dangerous situations. In addition, the quality of a finished product can be affected. When working with wood, a high feed rate may cause the motor to bog down. However, if the feed rate is too low, the tool may burn the wood. Some metals may fuse to the tool if the slow feed rate is used, and the same materials or metals may overheat and cause the tool to heat up if the feed rate is too high. In this activity, we're going to practice calculating cutting speeds that are going to be required for aluminum or steel when utilizing varying diameters of tools. You'll calculate the feed rate for a specific scenario also. So I'll show you how to do that stuff in a minute. So you're going to need your course binder for this. And procedure number 1, we're going to use the following formulas to calculate the necessary spindle speeds and feed rates based on tool diameter and type of material being machined. All calculations will be determined for high-speed cutting steel cutting tools, HSS tools. So we have this formula right here. It's N equals the cutting speed times 12 inches per foot, divided by pi times D. So N is what we are calculating. That is spindle speed with this formula up here. CS is the cutting speed. That is measured in feet per minute. And then D is the tool diameter. That's the little d right there. The next formula down, this is for feed rate, okay, is the following. It says FM, that's the feed rate in inches per minute, equals FT, which is feed in inches per tooth per revolution, and that's obtained from the machinist's handbook. We have a snippet of that machinist's handbook right here. This is a tool chart, tool feed. It's right here, tool feed, okay. That's the chart that we're going to be looking at. Also, you have NT, which stands for the number of teeth, and N, which is the spindle speed. So in order to get this formula, we have to calculate spindle speed first. So I'm going to flip this page over, and I highlighted something on here at the top. It says, number 1, show your calculation work on the 2.3.2 speeds and feeds calculation worksheet. This is that speeds and feeds calculation worksheet right here. Okay. You're going to be using cutting speeds for the following materials. For aluminum, you're going to use 200 feet per minute. And for steel, you're going to use 125 feet per minute. Steel is slower because it's heavier and harder material than aluminum. So steel you have to go slower with. So we're going to use these cutting speeds. Now, here we have number 1. Okay, this is material is aluminum, and the tool diameter is 1/2 an inch. So I'm going to take and get out my speeds and feeds calculation sheet. Now, what I did with this sheet is I put the formulas down here at the bottom. If you prefer to flip back and forth, between the front here and this page, you can do that. Okay, I guess you could do this to it too. The other thing that I did with this is I drew a line right down through here, through the middle of the box. I did that on both sides of the paper. And the reason I did that is because we're going to calculate spindle speed here on this side, and we're going to calculate feed rate on this side for each of the problems. So each problem has 2 answers. Okay, so spindle speed. The first thing is we have to know our cutting speed, and the cutting speed is told to us right here. This is the cutting speed. So we're going to use, for aluminum, 200 feet per minute. So I'm going to take and I am going to put cutting speed down. So I'm going to put down my 200, and that's going to be times 12 inches per foot. Okay, close parentheses, and that's going to be divided by pi times the diameter of the tool. And for this first tool, we have a 1/2 inch tool, which is 0.5. So this is going to be times 0.5. So that is the first problem, and that's how we set that up. Okay, now what we're going to do is we're going to do the math formulas for this, and I'm going to put my calculator on here. And the big secret to this is, well, I forgot one thing. This is feet per minute, and we have to have it in inches per. That's why we're going to do this little calculation here. So the big secret to this, if you're putting this whole thing into the calculator, is to use parentheses. So I'm going to put in my open parentheses, and I'm going to put in 200. Now I'm going to put in times 12, and I'm going to close parentheses. Then I'm going to divide that by pi, and I'm going to use the calculator value for pi as soon as I find it on my calculator here. There it is, pi. Oops, I'm going to backspace one. I got to use the open parenthesis. So it's pi times the tool diameter, which is 0.5, close parentheses, and then I'm going to hit the equal sign, and that is going to give me this value. Well, you can't really see it too well on here, but it's 1,527.887. We're going to round that up to 1,528, and that is inches per min. Okay, so that's how you do that one. Sorry about my light. It's the white calculator background. Okay, now we're going to calculate the feed rate, and the feed rate formula is right down here, and that is the feed rate is in inches per minute, and that's going to be times the feed in inches from the machinist's handbook. That chart I showed you, we'll use that. We also need to know the number of cutting teeth, and we're just going to use 4 for the number of cutting teeth for all of these, and the spindle speed. So that's the 1528 that we just calculated. So here we go. So feed rate, and this is it down here. This is the formula. Feet per minute, or feed rate times minute per minute, equals the FT, which again is the feed rate in inches per minute. So I get my chart right here, and I'm going to take a look for the material, which is aluminum. I'm going to go across, and there's different types of milling that you can do. You can do what's called face milling, or side milling, or end milling. We're going to use end milling for everything. And I'm going to come down, I'm going to come over to here. Now this has a feed rate of 0.005 to 0.010. We're always going to use the lower number for all of these. So 0.005 is going to be the feed rate for this aluminum. So I'm going to put in 0.005 times the NT, which is the number of teeth, which is going to be 4 for all of our things. I wrote that here. We'll assume a 4 flute end mill for all of these, times the N value, which is the speed right here, which is 1528, 1528. And again, I'll do my calculator. So I'm going to take, wow, that may be a little bit better. The numbers are bigger. So I'm going to take 0.005 times 4 times 1528, and that is going to equal, right there, it's going to give me 30.56 inches per minute. So this is going to be equal to 30.56 inches per minute. Okay. So, oh, actually, you know what? I goofed on this one over here. This isn't inches per minute. This is 1528 is RPMs. RPMs. That was my mistake. Okay. So we have 30.56 inches per minute. Okay, you're going to calculate the rest of these yourself. You're going to do number 2, which goes with this steel here. Use mild steel for the material on the recommended tool feats chart. I believe it's on there. Yeah, mild steel. So use that as your value, and you're going to go down and do all 9 of these. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then this one down here, number 2, you're going to calculate the feed rate when milling aluminum with a 1/2 inch end mill, providing that the feed rate per tooth is 0.002 inches and that it's 4 flutes. So you'll use this 2-1 right down here to calculate this one. You have to show all your work. So show your math, and at the end of this you'll turn this in. Of course, you have to put your name on it. Okay? There you go.